Hello and welcome back to App for You. So in this particular video I will continue my discussion on the left view of binary tree. So we have already discussed one of the approach of solving this particular problem using level order traversal, right? The time complexity was order of n. So using level order traversal we have already solved this particular problem. In this particular problem, as I said in the previous video, there are multiple approaches. So I'll be discussing another approach to solve this particular problem, which is nothing but a recursive approach. So in this particular problem, I shall be discussing a recursive approach to solve this particular problem of basically finding the left view of any tree, okay, any binary tree. Now, what is actually the concept? Let us understand in detail. So the concept works something like this: that we know we have a binary tree, suppose like this. So I have a binary tree: 1, 2, 3, 4 here, 5 here, and suppose 7. Alright, so this is the same example that I took in the previous video. Now basically we want to find out the left view of this tree. So we want to do so using recursion. So if you pay attention to one of the possible approach, we can find out that basically we are traversing from top to bottom, right? Top to bottom, and we are basically interested in finding the very first node of every level, right? The very first node of every level. So let me just highlight them. We are interested in finding the very first node of every level. So this is the first node of this level, first node of this level, first node of this level, first node of this level. How can we basically come up with another solution? So we are going to basically keep track of the maximum depth covered so far, max depth. Okay, we are going to keep track of this particular variable max depth, and also we are going to find out the height of a node. Two things. Using these two things we can basically successfully implement our algorithm. How? So initially suppose my max depth is 0 and my height is 1, which means suppose initially I am at this node. Please pay attention here very carefully. Suppose initially I am at this root node, okay, and I have a max depth initialized as 0 and height initialized as 1, right, and max depth as 0. So what happens is, when I am at a particular node, I will check if the height is greater than the max depth. So at this particular point, what is your height? Is 1, and is it greater than the max depth? True, isn't it? Because height right now is 1 and max depth is 0, which means till now max depth has not been updated, which means this is the first time in this level you will be updating the max depth. This is my first visit here, because right now my height is 1, the max depth is 0, means we have not updated the max depth yet. So if height is basically height of a node is greater than the max depth, basically update the max depth. We have to update the max depth to maximum value. So obviously among 0 and 1 is maximum, so max depth has been updated to 1, and since this condition was found to be true, that is the height was greater than max depth, which indicates that this is my first visit in this level. So I will basically store this particular value in output vector. Now recursively we will call on the first left subtree and the right subtree. So there will be a recursive call on the left subtree, means in this tree. So when there is a recursive call on this left subtree, and after this completes, then I will be doing a recursive call on the right subtree. Okay, so let us call a recursive call on this left subtree. So right now my height will be basically what? Initially it was 1 in this level, so in this level my height is 2. Is your height greater than the max depth? Definitely yes. What does it indicate? It indicates my height is 2 and max depth updated so far is 1. Means max depth we have just updated, we have just traversed till this level only. That is why max depth has been updated to this one only, and this is the first time I am coming to level 2, right, this level, and this is the first time I am coming to this level, and hence I found that the height of this was greater than the max depth. So if you found that the height is greater than max depth, what should you do? You understood that this is my first visit in this level, basically push that element into the output vector and update the max depth to the maximum value. What is the maximum value? Obviously you are in this level has maximum depth, so depth will be equal to 2. Got the point? Now if you find that the children are null, don't do anything, return. So the left subtree you have completely performed the traversal. What about the right subtree? If you perform the traversal on the right subtree, what is the height of this node? The height of this node is definitely h equal to 2, isn't it? Because initially it was 1 and here you will pass h equal to 2. So the height of this node is 2. Is it greater than the maximum depth? So please pay attention. Height here is 2, the maximum depth here is 2, which indicates that we have already updated max depth to the new level, to this level. Means we have already visited this level earlier. That is why we can find out the max depth is already 2. Which means this is not your first visit, because you can find that your height is equal to max depth. It is not greater than. Means this is not your first visit, and if it is not your first visit, and if you find that your height is basically not greater than max depth, you will not pick up this element into the output vector. Recursively call on its left subtree. If you pick up its left subtree, what will be the height of this node? Height of this node will be 2 plus 1, 3. Is this value greater than the max depth? Definitely yes, because max depth we have already updated till level this one. Till this level we have updated. We have not reached this level right now. This is my first visit in this level, and that is why I can find that my max depth value is less than the height of this node, because the height of this node is basically 3, right? The height of this node is 3. Okay, so assuming that the height is nothing but from the root, suppose. So height of this node is nothing but h equal to 3, and it is basically greater than the current max depth value, which indicates max depth has not been updated in this level. Means this is my first visit in this level. So pick up node 4 and update max depth to the maximum value of height. So it is 3, because you are in this level. Now its left and children are null, so nothing will happen. It returns. Performing the recursion on the right subtree, what will happen? You visit this node. If you visit this node, what will be the height of this node? The height of this node is nothing but 3. Is this value greater than max depth? Definitely not. Why? Because we know that we have already visited this level earlier, and we have updated max depth accordingly at that time. So that is why we can find that the height is equal to max depth and not greater than max depth, which means this is not your first visit. So if it is not your first visit, you will not put it in the output vector. So I will do a recursive call on the left subtree. It is null, it will return. Otherwise, do a recursive call on the right subtree. What is the height? Height is equal to 4. Is it greater than max depth? Definitely yes, because max depth so far we have updated till the 3rd level only, and right now I am in the 4th level. So which indicates this is my first visit in this level, because that is why you are getting the height of this to be greater than the depth. So we pick up this node because this is my first visit, 7, and then you update the height to the maximum value 4. Left and right children are null, so don't do anything, simply return, and you can find out that you have your output vector here, right? Your output vector have already been stored. So how can we compute this? Very simple. Again, as usual, you can see we are basically storing the output in this vector integer. So the traversal, basically this one will be stored in a vector of integer, right? Let us declare a vector of integer as usual that we do. Basically, so I'll be declaring vector of integer, name it as output, because my output will be stored here, right? What will I do next? As usual, I will just say output.clear, and I'll call a function solve, which will actually perform the computation by passing the root node to that. Once the solve function is executed, all the updates will be made in the output, and I can easily return the output vector. We have already done this, isn't it? It's time to write the function solve. So how do we write? Okay, one more thing. This time what we should do is basically, along with solve root, we should pass some more things. But let us declare a variable max depth. Max depth is equal to 0, isn't it? We know this max depth should be easily accessible from every node. This particular variable, right? This particular variable should be easily accessible from every node, because at every node I am comparing the height of that current node with the maximum depth at that instant. That is why I should pass the reference to this. So basically, suppose integer, okay, so suppose I'll pass solve the root node, and I'll pass the height of the root node, that is 1. Suppose h equal to 1. I said it, isn't it? I said here that h will be equal to 1. I said here, isn't it? H will be equal to 1. And max depth, I'm initializing it as 0. So I'll pass max depth address. So end max depth. Done. It is passed. Once this function is called, you should define this function. So solve function will be of void type, So a void type function solve, what it is going to receive is nothing but a root node. I have received it. It is going to receive a height, so basically integer h, and a reference to an integer pointer, right? Max depth. So max depth. So I'm writing integer star max depth because I'm just using the address of that particular variable so that I can easily access from every node, because I'll be involved in recursion, right? So I have to basically get the address of this max depth so that I can compare the current status of the max depth. So what I can do now is basically I will check if root is equal to null. So if root is equal to null, we know that if root equal to null, we clearly know we will just return, isn't it? We just say return. But if root is not null, what does it mean? It means there are some elements in the tree. So what we are going to do is basically we are going to check if height, okay, if height is greater than value of max depth, isn't it? If height is basically greater than the value in the max depth, that means the current value of max depth, which means what? This is my first visit in this level, only then this will be true. So we should basically push into the output vector, output dot push back, right? Because this condition, that is height will be greater than max depth only when this will be my first visit in the level. So I basically push the value of the root data into the output vector. Done. And then I should basically do what? I should update the maximum value. So value at max depth is equal to maximum of current max depth value, comma, the current height. Done. So I should also parallelly update this. That is what I was doing here, right? Like here you can see when I picked up, okay, sorry, okay, I just erased it anyway. So what was happening is basically we were basically, whenever we found that the current height is greater than the max depth, we used to basically push that particular node's value into the output vector. Why? Because this will be true, this condition will be true only when this will be my first visit in that level. We have already seen that, right? We will push it, and parallelly we will update the maximum depth to max of the current maximum depth and the current height. So the maximum value will be updated here in the max depth. Then what we should do? A recursive call on the left subtree and the right subtree. That is why we are going to do a recursive call of solve on root left. What will be the height of the left subtree? The node in the root node of the left subtree, 1 more than the current height. So h plus 1, comma, the max depth, right? The pointer max depth, because this max depth is now a pointer, isn't it? This max depth, whatever you have received, is now a pointer. So I just need to pass the address of that max depth. Done. This was the call on the left subtree. Similarly, you can do a call on the right subtree. Solve root right, and you can say h plus 1, comma, max depth, right? That's it. So finally, when this recursion will be completed, you will find out that you have already come up with your solution. So basically, if this is my tree 1, 2, 3 and 4, suppose a small tree. So initially your root is this, okay, I am keeping track of a variable max depth. So max depth initially is how much? 0, and my height is equal to 1. I am at this root node. Is this greater than 0? True. So push it into the output vector. I'll push 1 here. Done. And then what will you do? You will update the maximum depth to 1 because it was maximum. Then you do a recursive call on the left subtree. In the left subtree, what will be the height? Height will be 1 more than the parent, that is 2. Is this greater than the maximum depth? Because height is 2, maximum depth is 1. True. Indicates my first visit in this level. So include this node here. Left and right child are null, so do nothing, return. Now for this root node, you will call it right subtree. What will be the height? Height equal to 2, right? Height of this child will be 1 more than the parent, 2. Right now the height is 2 and the max depth is basically, max depth initially was 2, right? So you have used to update it 2. So now you come here, height is 2 and the current max depth is 2. What does it indicate? That this is not greater than this. If not greater than this, which indicates that this is not my first visit, because had it been, greater than this, it would indicate that it was my first visit, right? Like in this case. So I'll not include this in the output. Rather call its left child. Left child is what? 4. So this height will be what? 1 more than the parent. 3. Is this greater than the current max depth? Definitely yes, because the current max depth is 2 and the current and height you have is 3. Which means this is my first visit in this level. So include that particular value in the output. 4 will be included and update this max depth to 4. Now call its left child null, right child null. That's it. Finished. So what was basically your output? 1, 2 and 4, and this output will be returned in the output vector, right? So we are basically returning, so we should basically return output. Done. So that's all from this particular process. Let us see if it works fine and we are not doing any silly mistakes. Yeah, it works fine, you can see. And yes, that's all from this particular side. I hope this video was helpful, and this is another recursive approach to solve this particular problem. However, the time complexity remains the same, right? The time complexity still is order of n, right? Space complexity, in the worst case, if the tree is skewed, it can take order of n, right? But the time complexity remains the same, order of n. So yeah, I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. Thank you.